Okay, so we're back, and now we're going to do a couple examples that you can do on your own. So if you're watching this at home, what you need to do is just pause the video and check your answers after you've had a chance to actually try the questions. So here's the on your own questions number 1 and 2. It says, tell whether the triangles are similar, and then explain. Okay, well, your explanation is going to be either yes, they are because they have two pairs of angles that are congruent, or no, they are not similar because they don't have two pairs of congruent angles. So they're usually only going to give you something like this where there's only one pair and then you need to find one of the other angles. So let's do that. So for this first example, we want to find either x or y because we have 28 in common in both triangles. So what we'd want to do is let's just look at this first triangle and find x. Okay, so it's x plus 28 plus 80 equals 180. 28 plus 80 is 108, so it's x plus 108 equals 180. And then subtract 108 from both sides of the equation. And then we get x equals 72. So if this is 72, we now have a 28-degree angle, a 28, a 72, and a 71. So there's no way to get two pairs of equal angles because we only have one pair. This angle would either have to be 71 or this angle would have to be 71. So we say no, there are only, or there is only one set of congruent angles. So it's no. So let's try this next one. We have a 90 and a 90, and a 24 and a 66. So what we need to do is find either x or y. So let's do that. So we're going to do x plus 66 plus 90 equals 180. All right, 66 plus 90 is 156. So it's x plus 156 equals 180. And then subtract 156 from both sides of the equation. You get x equals 24 degrees. So if this is 24, we now have a 90 and a 90 and a 24 and a 24. So this angle here has to be 66. So the triangles are similar. So we'd say yes, they are similar because they have two pairs of congruent angles. So the third angle would have to be equal. Okay. So it's the equations you're solving are pretty similar to the ones you did in chapter 1. And you might be wondering why we're not finding this angle. We can, but we don't really need to because we know that 90 and 90 and 24 and 24 are the same. So this one has to be 66. We could solve it, but it has to be 66 because it has to equal 180. All right, so here's another idea from lesson 3-4, indirect measurement. It says indirect measurement uses similar figures to find a missing measure when it is difficult to find directly. So the classic example is you are trying to find the height of like a tree that's really tall, and you're going to use the shadow of the tree and the shadow of something smaller to see how tall the tree is or something like that. So let's look at one of the first examples that's in the textbook. Okay. So here's an example where we're trying to find the distance across a river, which is relatively difficult to do. I mean, you're not going to be able to hang a tape measure across the river. So what you're going to do is use some measurements that you can take and create two similar triangles. So it says you plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. Explain why triangle ABC and triangle DEC are similar. So we want to know this side right here, okay, what angle or what side, sorry, does that relate to in this other shape, okay? If we look at it, it would be this side here. So I'm going to highlight those in red, and then I'm going to take this purple pen, okay? This side here and this side here are the same corresponding sides, and then with this green marker, this side here and this side here are the corresponding sides. So when we set this proportion up to find the missing side, you need to make sure that you're comparing corresponding parts. So explain why triangle ABC and DEC are similar, and then also what is the distance across the river. So in order to be similar, they need to have two pairs of congruent angles. So they both have a 90-degree angle, but no other angles are labeled. So what we need to do is use the fact that we know that vertical angles are equal, so those two angles are also equal. So now they are similar triangles. Okay, it says because B and C are right angles, angle B and E are right angles, so they are congruent, and angle ACB, so ACB, that's this angle right here, and DCE, that's this angle here, are vertical angles, so they are congruent. So because the two triangles in ABC are congruent to two angles in DEC, the third angles are also congruent, and the triangles are similar. So check, they're both similar triangles. Or I'm sorry, the triangles together are similar. All right, now it says the ratios of the corresponding side lengths in similar triangles are equal. It says write and solve a proportion to find x. So what they did is they said x over 60. So what they're doing is they're relating the two sides that we highlighted in red, x over 60, and then 40 over 50, so the green sides. So when you set up the proportion, it's important that you compare corresponding parts. So they're comparing x to 60, so this side to the 60 side, and then 40 to 50. So when you solve that, the way they solve it is they multiply 60 to both sides, and that's totally fine. You get 48. A lot of times what you guys probably did in 7th grade is you would have cross multiplied, and you do 60 times 40. I'll do that over here. So 60 times 40, and then you figure out what that equals, and then you divide by 50, which is what they're doing right here anyways. So you get 48. So the distance across the river is 48 feet. Okay. There's other ways to set up the proportion. This is just one example. You just have to be careful that you don't compare parts that are not corresponding. Otherwise it won't work. So here's an example. It says, what if the distance from vertex A to B is 55 feet? So there's changing some numbers. So instead of 60, changing this to 55. Okay. Everything else about the picture is very similar. So what we're going to do is we're going to set up a proportion to solve this again. So what I would suggest is do it the same way. You're going to do like x over 55 equals, so this side corresponds to this side, and then they're going to, you'd want to do 40 over 50. 40 over 50. Now, if you did it the other way around, your answer wouldn't make sense. You'd get a length here that would be longer than 55, which wouldn't make sense. So I would maybe pause it and try to solve this proportion on your own. And then in a second, you can unpause it and then see how you do it. Okay, so here's what I would say is you're going to cross multiply 55 times 40. All right, so you do 55 times 40. 55 times 40 equals 2,200. So 2,200 equals this cross product, which is 50 times x. And then to solve that, you're going to divide both sides by 50. So essentially, you're doing 55 times 40 divided by 50. So you take 2,200 divided by 50, and it's 44. So x would equal 44 feet. Okay, so that's indirect measurement. There's a couple other examples we're going to do that aren't in the textbook. All right, so these are just some separate examples that are using indirect measurement as well. Okay, this one's a little bit trickier. So we're going to try to find the value of x. All right, so what we need to do is first make sure we have similar triangles. And we do because they both have 90-degree angles, and they actually both share this angle. Okay, I find it helpful to kind of highlight the two different triangles that are here. So one triangle is this little one right here that's inside of the bigger one. Okay, and then the bigger one, let me get a different color, this black color here, is this triangle that is this whole thing, so that the little red triangles inside of it, and it's a little difficult to distinguish the colors on the screen there, but we have this little triangle inside of this bigger one. Okay, so when we set up the proportion, you have to make sure that you're setting it up using the actual triangles. All right, so the little triangle would be, so here's a little miniature version of it. Looks like this, has a 90-degree angle. This is x, and this is 2. The bigger triangle is a little bit taller and a little bit longer. It's 90 degrees, and this is 1. Now, here's where some people have a little bit of a hard time. They'll say that this side is 1, but it's not. That's just that little short part from here to here. The whole side is 3, okay? So when we set our proportion up, we want to compare corresponding sides. You're going to say x is to 1, or goes with 1, as 2 goes with 3. So 2 over 3. So this is what we want to solve. X over 1 equals 2 over 3. So cross multiply, 2 times 1, 3 times x. So 2 equals 3x. Divide by 3, divide by 3. So this means x equals 2/3. 2/3. Okay, because that cancels out and you get 2/3. So x would equal 2/3. All right, one last example. Actually, I see there's 2 examples, so 2 more. All right, so take a look at this and try to solve it. You want to pause it because I'm going to go over the solution in just a second. So go ahead and pause it and try to do this problem. Okay, so first off, they're just telling us, hey, triangle ABC is similar to triangle DEC. So we don't need to prove that. They're just literally saying they are similar. So that step we don't need to do. So we want to find x right here. So again, we have a triangle inside of another triangle. So I find it helpful to just draw the 2 separate triangles. So I'm just going to draw a little miniature version of the small triangle. So here's a small triangle. And then the big triangle is just a little bit bigger. So it looks something like this. All right. And then I'm going to label the parts. So this would be DEC, and this would be ABC. Okay. So this is 11. This is 6. Now, let's see here. Let's see. The bottom of the short triangle is 15. The bottom of the long triangle is not 15. It's 15 plus x, because it's 15 plus this little part right here. Okay. So find the value of x. So this one's a little bit more complicated because part of the problem has an x plus 15. It's not just x. So again, compare corresponding sides. So when we set our proportion up, you're going to do something like this. 6 over 11 equals, so small triangle to big triangle. So a small triangle, again, to big triangle. So 15 plus x goes right here. So this is the equation that you're solving. A little more complicated when I have a 15 plus x. So you're going to cross multiply. So 11 times 15, which is 165, equals 6 times 15 plus x. Okay, so you're going to have to distribute this. Or I would suggest before you distribute, just divide the 6 right out. So divide the 6 right out of the problem. So 165 divided by 6 is 27.5 equals 15 plus x. Okay. And now you want to subtract the 15 from both sides. And that cancels out, and x equals 12.5. So we can just double check to see that it actually works. If you plug 12.5 in here and see if this works. So if I take my calculator and do 6 divided by 11, so I'm just going to check it down here. So 6 divided by 11 equals 0.54 repeating. So then 15 divided by, okay, now we got to add that. It's 27.5 because 15 plus x. Let's see if that works. 15, I can't see what I'm doing there, sorry. 15 divided by 27.5 is also 0.54 repeating. So it does check. So the answer is 12.5. X equals 12.5. All right, that's kind of a tricky example. Let's finish with another example of indirect measurement. Last example that we're going to look at, okay? So you have this person, and he is looking down at this mirror, I guess, and looking and seeing just the top of a tree. This actually does work. So you can, except for the line wouldn't come from the top of the person's head, it would come from where their eyes are, but that's not a big deal. So this person's looking down, seeing a mirror, and coming in, seeing the top of this tree. So we have these similar triangles. They're saying these angles are equal, and this is also a 90-degree angle here, and a 90-degree angle here. So they are similar triangles. So now we just need to set this up. This copy is not great. This is a 2, and this is a 2. So what we want to do is show similar triangles. So we're going to compare. We want to find the height of the tree. Let's call it x. So we're going to say 2 goes with x, or 2 is to x, as 4 is to 20. So you want to compare, like, okay, short side of the triangle to the short side of this triangle. So 2 over x, and then the long side of the triangle to the bottom of this triangle, okay? Then you cross multiply. So 2 times 20, 4 times x. Those are equal to each other. So 4x equals 40. Divide by 4, x equals 10. You probably could have figured that out without even doing a proportion. If you just see that 4, 4 times 5 is 20. So 2 times 5 is what this has to be. So that's another way you can kind of figure it out. So this is 10 meters tall, that tree. So hopefully this has help you understand what you're going to need to know how to do for lesson 3.4. So basically it's similar triangles. So proving that triangles are similar, and then also using indirect measurement to find missing parts of triangles. So hopefully that helped. And again, there'll be some other tutorial videos in there if you need to get some extra help, and you can always email your teachers. So thank you for watching.